Good morning, Bears. It is a Thursday, Friday epic. And we are going to start with a quick review of what we should have done by the end of the day, Wednesday, with Brandon's slide. Thank you, Brandon, for doing great work. If you remember, we were supposed to play with the sim or watch the video and show a slide screenshot with ice. He has it. A slide screenshot without ice. He has it. And then talk about the differences. Now, before we see what his says, if I just glanced at it before even reading his smart stuff, I would see there's more energy here. Look, way more yellows, little flares, less here. I would see up here he's got energy 0, heat, global average temperature 14. And this was at the beginning, right, with no time or anything. So no time. And then he ran it for 15 seconds. And now he's got energy 127. So within 15 seconds, he got rid of all the ice. That's pretty cool. Average temp 24, 10 degrees higher. And then he's got some energy up here. And then if you look over here, what did he do different? He blasted the sunlight. And interesting, even here at medium, there is ice. At max, though, he put up the carbon dioxide. He maxed out the methane. He maxed out the sulfur. And he put the nitrogen down low. Got rid of all the ice. So we're going to play with this thing again today. Now, for today's lesson, I'm going to do the sim for you. You just have to observe, and then you're going to take notes. So right now, by the end of the day, Wednesday, you should have your title. If it was me, Brandon, I'd put your name there. Then you have this slide. You have your temperature slide. You have your energy. Now, remember, if you just want to see and you don't get all this, just add visuals. I mean, look, I get temperature now. It's a thermometer. Oh, energy can come from windmills and solar and the sun. Oh, what's a trend? This doesn't help me understand trend because it just says trend, but you might have a picture that helps you understand trend, or you can just read it. A tendency, increase of data over time. Fluctuation, pretty obvious, things that go up and down or sideways or movement. Climate, a whole world, different climates. Climate change, things are going to change. The climate's going to change. Good job, Brandon. All right, let's dive into today's lesson. Down to about 46, depending on how many slides you had, you'll see a new word, absorb. Because you should have noticed that the ice melts and the temperature increases when more energy is absorbed by Earth's surface. So the more of this energy being absorbed into the Earth's surface, the more the ice melted. Why? Because this absorb is to take in energy, and that means the more absorption into the Earth, the more heat will go into the air, the more ice will be melted. Keep in mind, the ice is on the surface. Another interesting tip is when we did the reflection on the sim, when things bounce off of things, then it's not absorbing. So that reflecting meter, reflected, doesn't absorb. Not as much energy stays in the earth, more of it goes out, back out into the atmosphere. So that's why when you did that reflection high, ice started coming back, if you noticed that. The sim provides evidence the key concept global average temperature increases when energy absorbed by the surface increases. We don't know the whole story yet, but from what we've learned today, we can say that if ice is melting and temperatures are increasing, Earth's surface must be absorbing more energy. Next, we will investigate what could cause Earth's surface to absorb more energy. Thursday, Friday, epic. We'll go over this again in a minute. This is in groups. First, we're going to create a top slide. Sim Note Gas Effects. So the top slide is going to be called Sim Note Gas Effects. Let's do that now. So all you do, go to your top, click this, click your add a slide. There's all kinds of different ones. You can pick any of them. You can delete things if you want. So say you pick one with a box you don't need, click it, delete it. So this one I don't think we're going to need. So that one we might need. It's a good title box. What's going on with this one? Anyway, that one we don't need. This one's, why is this one? This one's not letting me click it for some reason, so we don't worry about that. This one we keep. This one, Sim Note Gas Effects or something like that will be your title. So right now, go ahead and open your slideshow. Go to your top slide and create one of these. Now, one thing, I'm going to give you a little trick on the sim for this to make your notes easier. I'm going to make that as big as possible. And you might have made a different version. Don't worry. You can make a blank slide. Sim Note Gas Effects. What we're going to do is we're going to cut and paste the gases here, and then we can write our notes next to it. So now if you don't know how to do this, you need to pause this video later, go back and watch. So quick people can open up, add a slide, and do their effects. All right, now let's come on down into here. The atmosphere is made of many gases. This includes the ones shown in the sim, as well as oxygen, nitrogen, and water vapor. So we're going to focus on these gases. Atmosphere, what are we going to do with this? Move it to the top, add pictures. Not right now, don't do it now, but we're going to move this to the top because it's a concept slide. Sophia's already done this. The mixture of gases surrounding a planet, that's our atmosphere. Why is the ice on Earth's surface melting? Increased energy from sunlight? Yes. Changes to Earth's atmosphere? Maybe. We're going to check it. Here are two possible claims that explain why the ice on Earth's surface is melting. Over the next coming weeks, we will investigate and refine these claims. Probably over the next couple days, because we're going to condense things. What kinds of changes to the atmosphere could affect how much energy is absorbed by Earth's surface? That's interesting. In the previous lesson, we learned that if ice is melting and temperatures are increasing, energy absorbed by Earth's surface must also be increasing. First, we'll investigate what kinds of changes to the atmosphere could cause this increase. Here's how to test atmosphere changes. Before each test, you'll let the sim run until the timer reaches 20. This will make it easier to see the effect of change. Now, I'm going to do this for you right here. And we're going to step by step by step. So we're going to add something to that top slide in just a second. Well, let's do it now. Watch this. Take this image. I want to show you something. I'm going to do this. I'm going to copy it. You have this. Copy that image. Move it up to our top slide. And watch this. I'm going to paste that image. I now have a beautiful way to do my sims. Now notice, I'm going to show you something. I'm going to shrink that. I want to make it just big enough so I can read it. So we have carbon dioxide, methane, sulfur, and nitrogen. As I change these, we're just going to write simple notes. So for example, I'm going to write carbon dioxide. Now you don't have to do this quite yet, but I'm just showing you what we're going to do when I give you this next little break. Then we're going to see what happens when we play with the sim. All right, let's come back down here. Before each test, you're going to run the sim 20 seconds. Make sure you only change one gas at a time. Now, you can do this on your own. If something happens right now, if you want to start working on your own, you can, or I will walk you through it right now. Otherwise, you don't know what caused the results. So we're going to change one gas at a time. We're going to write one little note about that gas, and that is it. Now, this graphing we'll do another time. So right now, simple. I'm going to play the sim. I'm going to change one gas at a time. You are going to open your slide and you're going to write down the changes. All right, let's do this. Here, if you want to play with it, here we go. Now I'm going to play it. I'm going to log in. Of course, I'm going to do all this. Give you a second, catch up right now if you need to. Get that top side. Okay, here we go. So I'm going to move this over just a little. Of course, it doesn't show the temperatures in my screen here. I'll have to, uh-oh, what's happened here? All right, I'll have to, what's going on? What in the world? Hold on. Okay, here we go. So, remember, here's the carbon. I'm going to do carbon dioxide first. Let's watch the changes. I'm going to try to get it so the temperature's in there. I think, oh, here we go. I think I can do it like this. Make this all smaller. I think it'll be in there. All right, here we go. So let's click. Let's go carbon dioxide. We go to 20 seconds and watch the changes. Temperature going up. Energy entered is going up. Energy exited is going up, but slower. And what happened to the ice? Temperature is going up. 20 seconds, stop. So at 22 seconds, you don't need to screenshot this. All you need to do right now, go to your slide, carbon dioxide, maxed out, what happened? Energy entered went way up, energy exited a little bit up, global average temperature up to 20, ice shrank. Write that down now. Now I'm going to reset. reset mode. Let's go to carbon dioxide is back to 0. Let's try methane. 20 seconds. Methane maxed out. Okay, methane maxed out. Temps going up again. Energy entered and energy exits about the same. We got 9 seconds. Watch the ice. Ice is going back. Ice is going less. Temp is at 19.1. We should probably screenshot that each time. All right, there's 20 seconds. So probably what we should do, if you go zoom this again, is screenshot this bar. So right now, you advanced class, screenshot this bar, and you could actually put it next to your methane. That was methane. So what happened? Global temp 19.8, a little less, but still very similar results to carbon dioxide all the way up. If you have a chance right now, screenshot this and put it next to your methane. All right, we're back. Let's reset it. Let's do sulfur dioxide. Ready? Max it out. Check your zeros. 0.14. Everything's the same. Bam. Oh, look at this. Exiting is now more than entering. Look at the ice. Is growing fast. Look at the temp going down. So sulfur dioxide, the more of that in the atmosphere, temps go down because energy's exiting faster than entering. 20 seconds, we stop. Screenshot this. If you can, all you have to do is screenshot this, put it next to sulfur dioxide, or just describe what happened. Remember, you can play with this sim on your own. Next. Okay, remember you should have screenshotted that and the other one. And here we go. Last one, reset, 0.1400. We're going to put nitrogen dioxide to the max and hit play. Ooh, look at this. Identical. Identical. Weird. Nitrogen dioxide, identical. What about the temp? Temp doesn't change. Temp doesn't change at all. Why? Because same coming in, same going out. Temp is going up a little bit, but nothing like before. Temp was at 20 on the carbon dioxide, 20 on methane. Got colder on sulfur dioxide, and now has stayed the same at nitrogen dioxide. So because of that, you can predict things. Screenshot that if you can. Okay, so you should have a screenshot of this. Let's do carbon dioxide one more time. This is carbon dioxide maxed out. And we're going to go to about 40 seconds, just so you can get a picture of it. Carbon dioxide maxed out. Oh, that was with nitrogen. I got to bring it down. Let's just see this one. Let's go a little past 40, see what happens. Wow. Lots of energy, but that's because we double tamed it, so don't worry about it. The temps is what we matter. So the temps changed about 20. All right. So this exited is about equal. It's comparative. You can screenshot that if you want. So now let's go back and see what we've got. What we should have, and I'm going to give you a minute to do it, is you should have carbon dioxide here. And remember, you copied and pasted this. You should have your methane, your sulfur, and your nitrogen. 1, 2, 3, 4. All you need to do is take these screenshots of how these changed, put them next to them, done. Or in your own words, what happened? Carbon dioxide went up in temperature. Methane went up in temperature. Sulfur went down in temperature. Nitrogen stayed the same. So remember that, okay? All right, that is it. Now, it is a Thursday, Friday epic. So the next thing you're going to do, we're going to do together in Zoom, not on this video, is we're going to come and read this article, the bonus article that I have linked here. We're just going to read that and see if we can corroborate some of our findings from this and then add that to this slide. So let's do that together. If you're on your own, just go read that article. It's right here in groups. Find 3 pieces of notes from the article. Paste it into a new slide, or this one, you can put corroborating notes, something like that. You can put something like corroboration with article, and then put your 3 notes here. Corroboration with article. Put your 3 notes in here. So now we've got these notes, 1, 2, 3, 4, about these gases. We have our article notes. Try to find notes that have something to do with gases. See if they corroborate. Don't have to. Just 3 notes from the article, basically. And A-level people will make this slide, maybe add another slide, 5-sentence CER summarizing your findings from the sim and the article. Remember, this is Thursday, Friday Epic. Everything's in groups. Have a great day, everybody. Let's do this.